the language of the universe.
But I don't understand it.
Welcome back, everybody, to the Math and Physics podcast. I'm your host, Parker.
And I'm Ray, and we welcome you to episode number 40, where today, as you can see, it's on Zoom. First of all, if you're on YouTube, you'll be able to see that you can see us now. And today, we are not talking anything mathematical, anything physical, but the philosophy of science.
That still counts.
I mean, okay, technically, it is still mathematical, I mean, at the end of the day, but it is the philosophy of it. So I think we mentioned this in quite a few videos, where, quite a few episodes, where we're going to be like, yo, we need to do a philosophy of science episode. Because philosophy in general, I think, is just important, to science. So I think it's really cool.
It's not just important.
Okay.
It's mind-bending.
Oh,
just
true,
like
true.
Just like the topics we discuss, anyways. Mm-hmm. But it's kind of like an outside view to, like math and physics, and kind of like it gets a little bit more mental, if you know what I mean.
For sure.
Before we get into the podcast,
some news.
Quick news. We're gonna make this nice and quick. Okay, first Zoom episode. Good
awesome.
News. There we go. Other than that, we are very close to 30,000 downloads.
Yeah, we're actually at 29, right? 29,000, something like that.
29,000 today.
Yep.
We are on track to hit 3,000 followers by New Year's.
That's gonna be crazy.
That's gonna be hype.
That's gonna be very nice.
Is there anything else? I don't remember. I think that's it. If you have any questions, make sure to go follow us on Instagram at math.physics.podcast. Mm-hmm. You can email us by adding @gmail at the end. And then Facebook.
The one news, though, is that this Zoom episode is not only our first Zoom episode, but is a trend setter. Because now every episode after this is going to be on Zoom. Yes. So... I think that's amazing. So, I mean, the main reason we're doing this, I think, is just so we can kind of give a YouTube audience, the chance to see us. Because, like, if you're on YouTube, you just don't want to look at a picture for 40 minutes, You might want to see people talk, see their expressions. So, like, every episode is obviously still on Spotify, but just has the option if you guys want to check it out on YouTube. Yeah,
and our YouTube is not like performing amazingly, so
yeah, that is also true. I mean, it's mainly because no one really wants to, I guess, watch a pictured podcast on YouTube, right? Like, yeah, for sure.
So, that's what's gonna happen. So
yeah, that's basically it.
Let's start discussing about the philosophy of science, philosophy of physics, and mathematics.
Yeah. So I think before we start though, in this episode, I think we're mainly going to be focusing on the physics and the math, not because philosophy of science. Like I think I was doing a little research before, and like there are so many different science fields where like philosophy applies. Like there's neuroscience, there's biology, there's chemistry. There's so many different versions of biology where philosophy applies. So I think today, just to keep it, short and concise, and with the name of our podcast, let's keep it in math and physics.
Mm-hmm. Mm-hmm.
Yeah.
So mathematics and physics. What is there to even talk about in terms of philosophy? Well, it turns out a lot.
A lot.
So math and physics is math more specifically is kind of an idealistic description of not even phenomena that we observe, but it's more like we have this mathematical like foundation framework that we established over the years, and it just so happens that physical observations fall into that framework very neatly, and it helps us predict more physical observations. For example, black holes that we talked about 2 weeks ago.
Ooh.
You know,
Last
we
week.
derived
No, 2 weeks ago. Yeah.
yeah, 2 weeks ago. We derived the mathematics. Well, we didn't, but
Yeah.
the mathematics were established, and Einstein said these objects exist in the universe, and it got proven. So this happens a lot with dark energy as well. We haven't really proven dark energy, but it seems to
the
be
math exists.
like,
That's it.
yeah,
Right.
the math shows that there has to be something that is intervening, that is affecting the mass in galaxies and the rotation rate, and we're just going to call it dark energy.
Well, technically, the galaxy
dark
rotation
matter.
rate is dark matter. The dark energy is the one that's expanding the universe. But yeah, I mean, basically similar trains of thought. And I think the entire idea of just philosophy of math, especially, because we can definitely go like math is just because it's so abstract, right? Like the entire idea of math, as you were saying, it's basically just like an idealization. It's something that we can apply to real things to predict certain things, but it's just a concept. It's very, very abstract. And that's especially why, like, in the proof classes and everything we're doing right now, it's incredibly abstract, which I think kind of gives us an even deeper, understanding of it. Because like by definition, like math is just so conceptual that it only, kind of provides you with the understandings to do things, in my opinion. Like,
and there are definitely many schools of thought behind like mathematical objects.
That is
like
true.
Well, I'm not gonna do a list, but
Okay.
anyways,
there are a lot of mathematical objects.
Yeah. One example. Okay, I'm just gonna stick with this example probably till the end because it's the easiest example. But numbers are mathematical objects.
That's the
right?
perfect example.
And so the first school of thought that I want to go through is intuitionism, right? And so under that school of thought, I guess, basically mathematical objects are strictly just mental constructions.
That is true.
And a number is just a mental construction. It's not a real thing. An integral, whatever. Everything, a matrix, they're all just these mental constructions that don't really exist. And the idea is that a single person or the collective, like the collectiveness of the human race are, we're advancing and creating more of these mental constructions as time goes, and they get more and more complicated with their applications and all that. But the idea is that the math is strictly in our heads. It is not separated. It's not a separate entity from us humans, right? And we're going to get into that other perspective in a bit, but the idea is that the math is only in our heads, and we are thinking of the math, and we are making the math as we go. And mathematics itself is infinite, right? There are an infinite amount of mental constructions that you can create, propose, and work into the weave of mathematics, and it will never be complete because our human race can create an arbitrarily large but finite amount of these mental constructions, but it will never paint the full picture of what mathematics really is.
But
and again, this is
like,
under no, yeah, go ahead.
Yeah, like even like numbers in general, right? Like numbers, as you were talking about, like how they just depict this reality that we're in. Like, to be honest, for another alien civilization, right? Like, who knows if they don't, maybe like their numbers are obviously called something else, first of all, but like obviously, they might be completely different than what we're used to seeing. So if we were to, like, even though the language of mathematics is kind of universal, we are still representing it in a certain language, like the language that we started it in, like numbers in general, right? Like the 1, the 2, the 3. like that concept is obviously universal, but the way we depict it, like in a matrix and all, like would you think that like another alien civilization would be able to understand it? Would like do you think that?
See, that's the issue with intuitionism. It's that like what you're talking about is basically formalism, which is that mathematics is a separate entity, and we kind of dig into the bag of tricks and pull out these objects that already exist in the universe, in nature, in
That is
other
kind of what's
realms
happening,
of
though, isn't it?
existence.
What's the other viewpoint that you were talking about?
Well, maybe. The intuitionism is that we are creating these ideas as we go. They're all in our heads. They don't exist anywhere else but in our heads. We can write them down, but when we write something down, it's for someone to read it and to have it in their heads.
It's not necessarily,
right?
True.
Writing something down doesn't put it into.
But the interesting thing about math, though, and this is where the math interesting part comes in, though, right? Like when you write something down mathematically, you know, or at least, I mean, this is kind of like how we're brought up too. Like we know that there is some physical object that can be represented by this. You know, like every mathematical object, like every mathematical intuition, for example, you know, has a reasoning behind it. So, like, for example, as you were talking about, you know, Einstein's theories and like a wormhole, for example, right? It exists on paper, but we've never seen it in the universe. Does that mean it just doesn't exist? Or does that just mean that we haven't seen it yet? Right. So, like, that's the entire thing.
It seems like you are a formalist.
Maybe.
You are a very heavy formalist in the sense. And I have this passage from a website that I will link in the description because these are very, very interesting articles. But so here's the passage, okay? Unlike the intuitionists, Hilbert did not take the natural numbers to be mental constructions. Instead, he argued that the natural numbers can be taken to be symbols. Symbols are strictly speaking abstract objects. Nonetheless, it is essential to symbols that they can be embodied by concrete objects. So we may call them quasi-concrete objects, right?
Okay.
So as you were saying earlier, like natural numbers, 1, 2, 3, you know, it's not just something we made up in our heads, but it can be literally represented by concrete objects.
Yeah.
Like, you know, one of this, one of whatever. And as you were describing, like, would an alien civilization be able to understand that? Well, you know, as a formalist, it would be, well, yes, you know, these mathematical objects are in the ether floating around us.
We're just picking them out.
And every intelligent being would, you know, eventually pick out these mathematical objects and see how useful they are. And natural numbers seem to be one of the most basic and most useful objects on the fundamental level. So yeah, exactly what you said. They would be able to understand, you know, eventually with basic translation to how we represent a matrix, they might represent it
in a little, of course,
a squiggly line or
maybe
whatever.
Something else. Yeah, I mean, not the same representation, but the same meaning is what you're saying. Like it's gonna have the same meaning universally as long as like we accept the formalist definition, right? So so with the formalist, sorry, continue.
Right, go ahead. I was just gonna say that there are many different other schools of thought when it comes to the philosophy of mathematics, and there are also branches from formalism, intuitionism, all these things. But I don't think we have a lot of time to dissect all of these. We do also want to get into philosophical ideas about physics and things like that. But I think what we talked about is very, very interesting and very thought-provoking.
And I think in types and numbers, in our episode on types and numbers, I also mentioned that I think negative numbers are the most conceptual idea, right? Like the first idea of negative numbers were thought of when people wanted to represent the debt that they had, right, versus the amount of money that they had, stuff like that. So I think I was just thinking about this as you were mentioning natural numbers. I'm just like, well, negative numbers are not, well, they can't really be represented, I think, as physical objects, right? They're simply conceptual. They're just in our minds.
and think about this. Like we have the natural or the integer number line, like, which is centered at 0.
Yeah, sure.
And we'll just pretend like it's centered at 0. But the reason I say that, if you didn't pick up on that, is because it extends infinitely to the right and infinitely to the left, which means that you can essentially center it at wherever you want, exactly. And it will be symmetric. But whatever. Let's just say it's centered at 0, right? And then we have the natural numbers that extend to the right, and then we have the negative natural numbers that extend down to the left. But what if, like, okay, I don't know how to formulate this, but basically we have -1.
Okay.
Right? And we have 1.
Yeah.
They're basically the same symbol, but with that negative sign in front. Okay? But they're different numbers.
Yeah.
They are not the same thing. And, same thing goes for every other number. There's like an asymmetric pair on the other side of 0. But what if...
Or a symmetric pair, you mean?
Yeah.
Like a symmetric pair. Like it's on
I guess.
Sorry, it's on the other side of 0, right? Yeah, like symmetric.
Sure.
Yeah.
And then what if we represented the negative numbers with different symbols? Like, it might not be useful.
So like instead of like 2, 1, 0, it could be like A, B, epsilon, C, something like that.
Yeah,
like,
and then but it still repeats in base 10,
exactly.
But just going backwards.
Just going backwards.
But because they're not the same number, of course it wouldn't be useful to us because we have things like absolute value.
I was just gonna say that exactly.
Like minus a minus makes a plus, so that makes it very convenient for us. But we have to remember that they are not the same number, right? Like a plus 1 and -1 are not the same number. So what stops us from using a different symbol to represent that quantity?
Again, that I just think it's just ease. That just might be just ease of use, just because it's easy to represent.
I mean, that's why.
Yeah.
But
we never. Yeah.
We had the option to.
We had the option. I mean, there were options. There were multiple options. It's just that we chose this one. We chose the easiest one. And I think like other numbers, like pi, for example, is not really a number. Like pi was completely conceptual, right? If I'm not mistaken. Like it was thought of originally as a conceptual just idea of the ratio of a circumference to a diameter of any circle, right? And I think that's like how the entire idea of pi came apart. And there are obviously many, many videos where you can see like how pi was demonstrated, and I think they're really cool. But the entire idea of pi, for example, too, just kind of makes you think about the philosophy behind it. Like, it's so interesting that this one number, or again, not really number, but this one object, mathematical object, just connects two like separated objects of the same. Okay, let me say it a little bit better. What I'm trying to say is like the circumference and the diameter of a circle, right? It's so seamless how pi can connect any two combinations of these, as long as obviously it's still a circle. So what I'm trying to, and obviously this is just the most basic example of pi. There's so many more uses, so many more places where pi comes up. It's just that it's so essential to the universe for us, even though it's completely conceptual. Like, it's not even a number. It's not even a finite number. It's completely irrational.
Yeah, and pi just never ends.
Yeah, exactly.
And that begs the question, like, why is the simplest, most perfect shape in our universe, it can only be described with a number that does not end?
That's so interesting.
Right? And this also leads to ideas in calculus and things like that.
Yeah.
Because it also begs to involve the ideas of infinitesimals and limits and all these things, because you can isn't there a way to approximate pi where you have like a square around a circle, and then what you do is the leftover that goes over the border of the circle, you remove squares from the corners. so you can remove like 4 squares.
Okay.
And then you'll have 8 corners, and then you remove 8 squares, like from the leftover.
I think
basically,
this is a number file
cut
video.
out.
I'm pretty sure. I'm pretty sure I've seen something. No, because like
maybe something
maybe
like
not
that.
what you're like. I think I know what you're talking about though. I think something similar to that maybe, but there's definitely an approximating pi. Or like this is how Archimedes, or was it Archimedes?
I don't know.
I don't think it was some.
I don't think that's how he did it.
Yeah,
no, how he did it. I know how he did it though.
Wasn't it
What
like
he
the
did is
circle, like the pentagon?
No.
Wasn't it
he
like
took
you draw
he
a
took
circle?
convex shapes.
Exactly,
And he drew
and
a
then you draw
square,
shapes
and then he
inside
drew
of
a
them.
pentagon, and then he drew a hexagon, and
Exactly.
then it got closer. But this was for the perimeter of a circle.
Yeah, but that's also how they
'cause
got
you can
pi,
easily-
isn't it? Because it's 2 pi r.
Yeah.
Yeah, that's also how they got pi, or pi. No, wait. Yeah, the circumference. That's what I
Probably.
mean. Right. The circumference of a circle or perimeter is just pi d. Right. So
Wait,
like,
can you get pi? Like, is there a way to mathematically get pi
what do you mean?
by taking a limit as like the number of sides?
Yeah,
of
that's
your
literally what
polygon
they did. I'm
goes
pretty
to
sure.
0?
I'm pretty sure that is what they did. No. They were like expanding, like increasing the number of sides.
I know.
Like it started with a square, pentagon, and went to like insane number of things until they tried to, approximate the length of the sides, right?
But listen to my question.
Mm-hmm.
The question is like, is there a formula that can give you the perimeter of an n-side polygon? And then if you take that formula, take the limit as n goes to infinity, and then you divide by 2r or whatever, would you get pi?
That is a fantastic question that I'm pretty sure we can ask Google. I'm not gonna lie. Of an n-sided
that would be kinda
polygon
cool.
I mean, it's definitely an interesting question
Because you would get
then you can
2
just
pi
take the limit.
if you take a radius of 1 and you just take 2 pi. Except polygons don't have radii, so
Oh wow! Listen to this. The
What?
perimeter of a polygon with n sides with side length s is ns. That told us so much. Wow.
that's
Wow.
hilarious. Wait, maybe check the ratio.
There's probably some angle, like with the angles, or like no,
Yeah.
no. But the sum
No,
of
I
all
was-
the angles are always the same.
I was gonna say the ratio of side length to number of sides, but I don't. That was a dumb idea. That was just
Okay,
a
maybe we
stupid
can talk
idea.
about this later. Think about it for sure.
Yeah.
But I mean, that's how I think. I'm pretty sure. I think that's how they approximated pi. Because I'm pretty sure there's a video on this on YouTube where like they pretty accurately show you, or like on Numberphile, where they show you how, you know, as they start adding more and more sides, you can approximate this thing that we now call pi. And it's, I mean,
Yeah.
it's so interesting how you can, how the entire idea, like the idea of pi even works. You know, I just love that. Just mathematical philosophy. It's amazing.
So I wanted to also talk about like AI/computer stuff.
Oh, philosophy
So-
of that. Okay.
So my first question is, you know, will we ever reach a perfect description of reality? Is that even possible? Does that even exist? Right. I think in my opinion,
Okay, yeah, go for it.
right, in my opinion, if a perfect description of reality does exist, which I will come back to the idea that, you know, does that even exist? But let's assume it does. I think the only way we will reach it is with computers and machine learning and artificial intelligence. Because I think at some point it takes, like, with genii, is that how you say it?
What, like multiple geniuses or something?
Yes. Yeah.
Genii? I don't think it's genii.
Okay. Anyway,
They're just
geniuses.
very smart people.
Okay. with very smart people that have thought of like revolutionary ideas in math and physics, or anything for that matter.
Mm-hmm.
You can use your brain very effectively.
True.
You can jot down your ideas, and you can do all of that stuff to reach like one pillar that will revolutionize the field
Yeah.
you're working
Okay.
in. But what if your brain could act as 1,000 brains working simultaneously at that one topic?
That would be
imagine
essential.
imagine if Einstein was able to communicate like instantly with different but same level of intelligence copies of himself in the same room. What would have happened then? Like, crazy things would have happened, of course, but he was alone mostly. He was just chilling, doing thought experiments in his head. But imagine if he could communicate with people that were as smart as him, but in different ways, because nobody is the same type of intelligence, right? Some people are more like visual.
I can definitely
whatever.
see that. Yeah, I mean,
All that
artificial
stuff.
intelligence is definitely where we need to go if we're going to solve for any true description. But I think you were going to continue by saying, if you do believe that we can ever get to a true description of reality.
Because okay, this is going to be like a
is a
next
big one.
level thought right
This is a
here.
big
This is
one.
the
Okay.
next level thought.
Let's hear it.
So is there a true description of reality that can be written down concisely? Because as we know, if you can't write it simply, then
You don't understand
you don't
it.
know it at
Well,
all
no.
or whatever. Yeah. Anyways, my thought is that we can't know the answer to that yet, but we will be able to know the answer. I don't know how soon. That is always the big issue, but here's why. So my 5 senses, right? Actually, there are more than 5 senses. Like, for example, your sense of balance.
Oh,
That is
okay.
a sense.
I guess that. I mean, that's not really a
you know.
sense, though. Like,
Yeah, I mean,
what?
I mean-
you can't say that's a sense, man.
you can touch, you can see, you can taste, you can smell, you can hear, and you can also know when you're falling. Like, it's something that you do anyways.
I guess that's.
Whatever.
I mean, okay.
Whatever.
Okay, continue.
Also, sense of temperature. You can feel when something is cold. It's not the same thing as touching like something that's sharp.
But
It's
that's
not
just
the same.
bro. You can't.
That's not the same.
That's not a new sense,
Okay.
man. That's not a. We have 5 senses.
Okay, just
We have
listen.
5
Just
senses.
listen.
Okay, continue.
Just listen.
Continue.
So there are these senses that we have, right? We evolved them over time, over long periods of time, because at one point we were just a single cell. Mm-hmm. And so at some point we didn't have eyes or ears or noses, but we evolved these senses based on the needs of survival and the needs of our environment, our planet, etc. Okay, we are carbon-based life. We are, living on a seemingly unique planet,
Yeah. Okay.
and there is nothing that tells us that our senses are the only senses that exist. Right?
That's true.
There are bats that communicate with, what is it, like ultrasonic
Yeah, I
waves or
think-
where?
Just like
Something
sonar.
like that.
Sonar.
Yeah, sonar,
Sonar.
right? And we can't hear that stuff. There are. I know there's a lobster that has 21 cones in their eyes. They can see, like, we have
That's
3.
amazing. Yeah. That's
We have
amazing.
we have 3 cones, and we can see, what is it, like 16 million colors or whatever, something like that.
Sure.
There's a wide variety.
Yeah.
There's a lobster
Imagine
with
what a
21.
lobster
like,
can see, man.
Like what is this guy seeing?
Oh my, that's amazing.
This lobster is seeing like infrared, ultraviolet
He's seen everything.
stuff going
He's seen
on.
everything.
Wild, bro. Colors I can't even describe. And so, like, what tells you that the experience that we're having on Earth in our physical reality is the full experience? There's nothing that's telling you that at all. Mm-hmm. We are experiencing reality because signals are being fed into our brain, and our brain is responding to those signals. Like touch, it's just electrons interacting, and then those electric signals get shot into your nerves up to your brain. Same thing for taste, smell, quantum smell, whatever.
Yeah.
Hearing is just vibrations, man. Like what tells you that there's not some vibration that is moving through us constantly that we are not picking up? What if there's a civilization that is screaming at us saying, yo, we're here,
We're
dog.
here, man. Come pick us
They're
up.
saying we're here, but those signals are going straight through our skin, straight in between our atoms, and we're just never receiving those.
Well,
at all.
Actually, if an alien civilization was sending out signals, we would have probably caught it. Like, we have a lot of satellites and a lot of radar dishes and stuff.
But
yeah,
Ray,
we would have not caught it. We would have not caught it personally.
What if electromagnetic waves aren't the only type of waves? Like, what if there's
I mean, that's okay.
what if
that's
there's
crazy.
what if there's like a weird wave that travels always
gravitational
perpendicularly?
waves is one.
But listen.
Yeah.
There's it's a way to send information, right? You can send information, and it always travels orthogonally to electromagnetic waves, and we've never been able to detect them, but it's still a way to send information.
Yeah, I mean, it could be sent on like a higher dimension for all we know, and we don't even we can't even detect it.
Like electromagnetic waves travel along a plane, but these waves travel in the cube around the plane.
Yeah, they could. I mean, who knows exactly, right? Like they could.
But
they could.
I think
this is the question.
But okay, this whole tangent.
Yeah, you really went off. Eh?
It's just to say that the point at which we will know whether a full description of reality exists is when we first write out an exhaustive list of transfer of information, right?
Okay.
That's the first thing. Like, how many ways are there to transfer information? That's the first thing we need to know. And we will only figure that out with AI and machine learning.
That is true. I think that's going to help.
There's no way that a human with a human brain is going to be able to figure that out. Okay?
That is true.
And then second of all, we need to adapt or convert all of our physical theories to those higher levels of information transfer, or like not even information transfer, but just like ways to absorb reality, right?
Yeah.
Like all these different types of I was thinking the other day, I think I was in the shower or something, and I was just bored, just thinking of things, and I was like, my physical reality doesn't really exist, right?
True.
I see things.
We see things
because my brain takes in these electromagnetic waves, and your brain converts that into like, okay, there's an object there and an object there. But in reality, like if you take your eyes and your senses out of the equation, like the universe is just like an empty, just black, like not even black, like no color at all, just information passing, like just
I'm not gonna lie,
around.
This is kind of getting into the reality of our universe.
Yeah.
Which I think
We
you
will
know
talk
something
about that. We will talk about that later.
Yeah.
We do have an episode planned for that.
Yeah, we actually do.
But,
I think that's going to be definitely, I mean, because what you're talking about right now is basically that, right? Like the reality of our universe.
Okay, you know what?
To answer the question, though, like,
wait, wait.
Okay, continue.
1 second.
Yeah.
Before I finish saying what I said,
Okay.
if you enjoyed what I was going to say and engaged in that idea, I'm gonna leave you on a cliffhanger, okay? Because we did have an episode planned where we're going to talk about the nature of reality and the nature of being an observer in our universe.
Exactly.
So make sure to tune in.
That's gonna be hype. That's gonna be cool. Soon.
I don't know if it's going to be our next episode, but it's going to be soon.
It's gonna be soon.
So make sure to tune into that. But we're gonna head back to mathematical physics philosophy.
So answering the question now on my part for when will we reach and if we will reach a perfect description of reality. To be honest, like I don't ever see us truly reaching that. Like as a species, I don't see us ever truly reaching a complete description of reality, because I simply think it's impossible. Because even if we had the strongest, like the best in class AI, and we were, 1,000 years ahead or 2,000 years, ahead, we were absolutely amazing with technology, reached the technological singularity. Let's say all those assumptions are valid, and we have next level AI. The thing is, the universe is still not letting us know all the information, right? Because the entire idea of the expanding observable universe is that as the universe is expanding, things that are really far away we will never ever get to see. We will literally never see some parts of the universe. Like, that's just how it is. So because of all of these things, and also, as we were actually talking about in our quantum mechanics class very recently, to get a full description of, a system, like a complete description, we would need to know possible states of this particle throughout the entire universe. And like when we were talking about forces and stuff like that, we were talking about particles that, are on other ends of the universe, how they can influence each other. So at the end of the day, to have a complete description of reality, we would literally need to know the position and possibly momentum of every single particle in the universe. To have a complete description, a full description of where everything and what everything in the universe is doing.
Which is not possible because of the uncertainty principle.
Which is not possible because of the uncertainty principle. Exactly, that's what I was getting to. So this thing called the Heisenberg's uncertainty principle relates these two observables, what we call it, the position and the momentum of a particle, that can never be known at the same time. We can never know both the position and the momentum, and that's basically all the Heisenberg's uncertainty principle states. So, like, if we just can't know what we need to know to get a complete description of the universe, we just can't get a complete description of the universe. And that's basically my school of thought, that I think that it might exist. It exists. But I don't think, with the laws of physics in our universe, I don't think we can ever actually get to know it. We will never truly unlock it. It's like a treasure chest that can never be opened. And that's kind of like what I think of the...
I disagree.
Yeah, I mean,
to be honest,
it's
I think...
two people, different opinions. Their choices.
I think the uncertainty principle... Well, I don't think, but, the uncertainty principle is an actual thing.
Yeah.
that we use to calculate many, many things. For example, the fusion temperature of stars. Like our sun is not hot enough to fuse hydrogen into
That's
helium.
tunneling, though. That's not really uncertainty principle.
Yeah, it is uncertainty principle because the what's it called? The atoms have, or no, the electrons have a certain velocity, a certain kinetic energy, but because of the uncertainty principle, they can tunnel through.
Yeah, well,
the
tunneling
Coulomb
is what
barrier
causes
force.
it. But yeah, okay, uncertainty principle is what allows it to happen.
Because
True,
it's because
true.
of the uncertainty principle.
That is true.
It could be the case that we find it on the other side of the Coulomb barrier
Exactly.
force, and that's what sets off the fusion of hydrogen.
So basically
of
what he's
hydrogen.
trying to say, like the entire idea of fusion depends on this principle, right? And this principle gives rise to quantum mechanical phenomena such as tunneling, which makes it work.
It doesn't always necessarily depend
It's just that
on
a lot of, like, for example, our star, as you very clearly stated, is just not hot enough, but it's still very clearly a star, right? How is that happening?
Exactly.
Because of this.
like it's still on the main sequence, which means that it's burning hydrogen. And we noticed that it, like, the core was not hot enough to do that. So we had to look for reasons why. But
Exactly.
the point is, what I was going to say is that I think that there is like a missing element to what we know about reality. Like there is something more important that we're just not taking into consideration, where yes, the uncertainty principle holds, but with this missing element, we will be able, like we won't know the position and momentum of a particle, but with this missing piece of information, we're going to know everything we need to know about the particle to get a full description. Like even though we don't know position or momentum at once, we're going to have enough information to describe it perfectly. But we don't know what that is yet.
Yeah, but can we do that for every particle in the universe, though? That's the real question,
AI.
right? Like
AI.
one day.
Eventually.
I mean,
Like what if
that's the whole thing, right?
like the AI is going to become, like there's no limit to how powerful an AI can become. An AI can program itself. Eventually will be able to program itself to become exponentially smarter than it already is, at that point where it is already smarter exponentially than human beings are. So like it's going to discover things about our universe much quicker than we are. And I think AI is like 100% the future. And one reason why I don't think AI is going to take over the world is because like a lot of people are scared of AI. They say, okay, they're going to control all of our resources, they're going to enslave the human race, whatever. The problem with that is a very mortal fear. Like the fear of being exploited and taken over is a very mortal idea. And you have to remember that the AI is just a machine. They don't care about anything, right? Like you can't threaten to kill a machine. The machine doesn't care, you know?
Exactly.
It's like, oh, I'm going to remove your battery. It's just like, okay. Like,
okay.
Like,
do what you got to
like,
do.
I don't, like, I'm not, like, I don't care. Like, whatever. Like the AI has more pressing things to do,
True.
right? Like what's the point in taking over the world?
Exactly. Like they're not really gonna get an advantage over that. Like they
where
realize the Earth is really not worth much. So like it's already we've already kind of destroyed half of it. So people are like they're gonna be like, I don't want this.
The AI already knows. The AI comprehends vastly more than a human, right? It understands that the universe is more important than the Earth. It realizes that there is more information out there than even it can hold in its I don't know how to describe it.
Memory?
In its cloud, let's say.
Okay.
And so there, like, there's no, like, dominance is literally like a tribal instinct that
I know
we
it's
have.
not really a machine. Like it's not really a computational. Like as you very rightfully said, they wouldn't even care. Like why would they do that?
Yeah.
It's so
Like
human
by
to even
nature-
think about that happening.
Yeah, like by nature, we are scared, we are intimidated by things that are bigger and stronger and smarter than us, right? Like if an alien civilization comes, like, I don't want to point any fingers, but some people on this planet will be taking their guns and shooting out at the spaceship. You know what I mean? Like they're gonna be scared. Their first instinct is going to be defense. Like there's something that is smarter, more advanced than us. We need to take cover. We need to send bombs. Like we need to get this thing away from us. Like that is very instinctual and very primal and very like we need to get over like borders. Political
But
arguments.
that would be like in a very, very futuristic Earth.
Yeah,
like hopefully.
definitely.
Yeah, this is not anytime soon. Anytime in our lifetimes, unfortunately. This is gonna be like in a good 2,000-3,000 years. Like I'm not like when because politics and all these borders right now that you were talking about, man, that's like the perfect description of how science or like technology in general can really never truly advance. Like unless we have everyone working on something together, you know, like as one. Like right now there's so many disputes, there are these problems, and the politics comes into literally everything.
Yeah.
Like NASA's budget is now all politics. Like, why does that matter? Like, it's so stupid, you know, but it's so important, unfortunately, to the world we're living in right now that we can't do anything about it. But in a world like 1,000 years later, I can, like, if we were, you know, to truly come together as one and, you know, work together, and we had some next quality AI, well, technically you're right. We never know what the AI can't do, because it can probably teach itself to do everything. You know, that's the thing.
Exactly.
That's the whole idea.
Exactly.
Yeah.
And here's a crazy idea that I got from the Joe Rogan podcast, which everybody who's listening to this already knows what that is.
Probably. Hopefully. Yeah.
I don't remember which episode, but I just remember the idea that was being discussed. And it's that humans are the reproductive organs of the machine world.
Oh.
And if you think about it real hard, it makes a lot of sense. Okay? So what have humans kind of been leading up to since the dawn of time, right? We have been making fires, making tools, making transportation. But why? Like, why do we have schools? Why do we have universities? It's to transfer knowledge, to increase our knowledge database. But why? Like, why? Naturally, technology falls into that, like, final destination, right? Like all these years, like thousands of years, kind of leads up to the point where we can build something that can teach something to us, right? Like, we build something and they turn around and teach something that we didn't know before that.
Exactly.
And so, and we can build something that is more intelligent than we are. And so if you think about it, who is the real intelligent being in this case? It would be the computer that is smarter than us. So if you think about it in kind of this, like, long process, this long, like, reproductive process, like, humans are just the organs, right? That produce the machine world. And once the machine world is going to be mature enough to be independent, like, obviously they won't need us anymore, you know? Like they might just take off, you know, like, whatever.
True.
But
you never
like,
know.
I can't really tell you what's going to happen in the future.
You never know.
But, you know, of course, like, this is really hard to describe, but it's going to be kind of like a parent-child thing. Like, they're not going to, like, in my opinion, they're not going to take over the world, because we are, like, that parental figure.
Kind of what
they
made the process in the first place.
Exactly. And, you know, they're not just gonna ditch us and whatever, but of course we are mortal beings, and technology, you know, as we know it, isn't really mortal. Like, the physical aspect of it, like the hardware is, but the programming, what am I trying to say here? Anyways, the whole, like, the entity itself is not mortal, right?
I mean, it's not conscious. Yeah, like programs aren't really conscious. Like, they're not things. Maybe conscious.
Not yet.
But, like, conscious is a whole another, you know, topic where we can get into, like, the philosophy of consciousness, especially with AI.
Yeah.
Right. Like, if we make it conscious,
actually,
you know, and they can completely like, I think I already mentioned this before, but Westworld, amazing TV show, and it's basically about, you know, making these machines conscious, and then to the point where they actually believe they're conscious and just literally take over. But that's obviously a TV show. But in reality, well, like, conscious beings are a whole, you know, it's definitely a topic where we can get into the philosophy behind making a conscious, you know, some technology that is conscious. Like, if we were to do that, what does that even mean? That means the technology that what we just made can supposedly think for itself. Like, that entire idea has a whole philosophy behind it, because to give something life, you know, rather than like create it. Like you're giving something life. Like that whole idea is just something that we've never really, you know, discovered before. Something we've never really done before. It's definitely something that we can do in the next few years. Like, I mean, I'm not even joking though. AI is definitely becoming more popular. Like, technology is ramping up right now at a very much exponential rate. Bad for the earth, but it's good for technology. But it's happening, I mean, at a rate where, you know, there are a lot of AI bots. There are these AI, you know, there's this very famous AI dog that I don't know, you might have seen on Instagram, like this robotic dog. It's a very, very famous tool, basically. And there are just so many things that's being created nowadays with artificial intelligence or just machine learning or just some kind of, you know, engineering background, and that just becomes into its own entity. Now this robotic dog, right, that was created, obviously not conscious just yet, not even close. It's going to take maybe hundreds of years for it to fully for us to get to AI, you know, that singularity, that boundary. But until we get there, we can just play around with these things, and these machines are actually helping us already, you know, discover crazy amount of things. Like the Google AI, I think I spoke about, which is like, you know, helping us discover planets and Goldilocks zones of solar systems and stuff like that. So it's just really helpful. And if we can truly get get conscious AI, that would be a whole other story, man. That would be so interesting.
All right.
Okay, so it's kind of bordering on a little late, even though we didn't really get into too much on the philosophy of physics.
Do not worry.
I think we can do an episode on that.
For our next, instead of making an episode on like the reality of the universe, we'll just make it like a part 2 in this series, but we'll still call it like reality of the universe, whatever. I
mean, to be honest, like, because we can start talking more about the philosophy, right? Like the philosophy behind it.
We'll just have like this, like, I don't know, maybe because we did history of physics once a month so far. Yeah. We can do this maybe like every whatever. But this is a good topic.
It's definitely a nice topic to talk about because it's so conceptual, so we can just, you know, keep going on and on about it. You know,
we do have more stuff to talk about.
Well, very much so, but we can maybe distribute that into a part 2 because it's not enough for me to just finish up this episode. Like, it would easily be another 10-15 minutes, and that's, you know, borderline
probably
long.
More, to be honest.
Sorry?
Probably more.
Yeah, it's probably going to be more. It's not going to be 15 minutes. It's going to be more than that. So, we can maybe make a part 2 on this. This was more of like a philosophy of math and like truly understanding like why. I mean, not really. It was kind of.
I mean, we kind of went off the rails.
Yeah, we did.
Whatever.
We went on math. We went to descriptions of reality. We just went to philosophy of the universe. So we kind of just touched around in many places today. It's kind of cool.
All right. So we're going to end this episode of the podcast right about now. Make sure to send us your thoughts on Instagram at math.physics.podcast. Email, just add at gmail.com. Facebook, same thing as our Instagram. We have a Twitter now.
Oh, true.
We have a Twitter.
We didn't even mention this. We have a Twitter.
And
we have a Twitter.
Oh, wait, what is it? What's our Twitter? I think it's math.
We're going to be basically posting every
physics.pod.
What? I'm going to tell you right now cuz I'm currently checking. Our Twitter handle is at mathphysicspod. Yeah. Capital M, capital P. Capital P.
Math Physics Pod, because we couldn't write out the whole name. Yeah. It was too long.
It was only a maximum of some certain characters. We couldn't fit it.
So, follow us on Twitter. Tweet at us. Maybe ask us a question.
Oh, yeah. That would be amazing. Go for it.
Oh, yeah. We are... Okay, we have had some people request topics, and we are not ignoring you guys.
For sure.
We've had a request to talk about neutrinos.
Still,
which
is going to definitely come up into One of the
which we
episodes
do
we're
not
gonna do
know a lot about. Okay.
Yeah.
We like doing research on philosophy is a lot easier than doing research on neutrinos and
sure.
actually being able to produce a podcast episode about it. So maybe give us some time. We are in final exam season right now, so
is
maybe
also true.
that episode won't come out for a little bit.
Interestingly enough, actually, Parker and I are kind of taking a lot of time out of our day today to record this, which is pretty cool because we both have like 2 exams next week. So, you know, this is what we do. Had to, yeah.
So, make sure to follow on Spotify. We are going for 3,000 followers by the end of the year. That is our goal.
And
also,
subscribe on YouTube. I'm just saying.
I was about to say.
Because we never say that, you know, because no one really checks our YouTube out. But subscribe on YouTube, you know, go like it, go subscribe. And obviously, like, I mean, if you have seen our YouTube, you know that every episode goes up on YouTube anyways. And nowadays, all of them are going to be Zoom. So wouldn't you love to see us? See what we look like? See our expressions
Make
when
sure
we're talking?
check out the YouTube. So, this has been episode number 40.
40.
The Math and Physics Podcast. We will see you next time. I'm your host, Parker.
And I'm Ray. And we will see you soon.
Bye, guys.